Hey everybody, today what you see on the screen, we're going to go through changing to vertex form, but this is really a supplementary video. So you'll notice at the bottom, we're going to complete the square today. I went through and completed the square with you on two problems. One on our generic quadratic function from standard form, so we could understand where our negative b over 2a came from. And then secondly, I dealt with one mechanical example. So what I want to do with this video is I want to take you through completing the square for all the same functions that we originally addressed, just so you can see the process in a little more detail. You can pattern it out a little more. It might be the sort of thing you can pick up and use whenever the numbers allow. I shouldn't even say allow. Whenever the numbers make it easier and quicker to. So what I want to do, I want to spend that time working through those same problems, okay? Here we go. This is what we started off with, the idea of a standard form to a vertex form. This is kind of where we're coming in, the benefits of being able to switch into vertex form. And this was the problem that we went through and we dealt with regards to completing the square. So what I'm going to do is I'm going to complete the square on it again, but I'm going to talk a little more detail, or a lot of extra detail. I'm going to actually describe the process pretty clearly, I hope. So for us to complete the square on this, we first want to factor out that leading coefficient from all terms that contain the variable. That's going to give me a coefficient of 1 in front of my x squared, which is what I want. Now I need to figure out what value could I sub into my brackets that is going to allow that inside to be a perfect square trinomial. So I have that little algorithm. I can take my coefficient on my x, my single x term, that -8, and I can go through a little process with it. Since this is going to be a perfect square in there, then two of the same thing had to come together to give me -8. So what I'm going to do is I'm going to divide that by 2. That gives me a -4 value. That -4 then needs to be squared, and it's really hard to denote a squared when I don't have a base, but you get the idea. And that is going to give me +16. I'm not even going to write the positive in just because every time we square something, we get a positive. But that becomes the key value that allows me to complete the square. So I'm going to go back to my brackets now. I can put in a +16. There is my perfect square trinomial. That's what I wanted. The problem was that green just caused me to change the value of the function. So if I subtract that 16 off again right away, you'll notice the result of my two green terms is 0. So I didn't really change the value of the function. Okay, what I underlined in red, that is my perfect square trinomial. So I want to get rid of that -16 term I was stuck having to put in. That means I'm going to expand it out of the brackets. That is going to get me to this line. And this would be a line that you're going to notice I'm going to stop writing in because I think we can jump it, just blindly expanding out that negative term. Because if we know we're going to be left with a perfect square trinomial, then let's just factor it anyway. Yes, I could factor that. Two numbers will multiply to give 16, add to give -8, but I don't want to. Remember, I actually calculated this before. Can you see my two blue -4s? I already figured it out up here on the right. So I didn't really have to put a whole lot of thought into me putting in that -4. I knew that that was going to be the inside of my factor. Okay, now I can collect my -32 plus a 25 gives me a -7. And you will notice that that equation is now in vertex form. There we go. There is a completing the square. And that is completing the square, probably, I would argue, with some of the easiest numbers I could work with. Okay, the rest of the day is just seeing that process and how it plays out when, let's just say, the numbers are not as cooperative as what those may have looked like when we went through there. Okay, let's jump into the next one. Okay, you take a look at B. I'm going to argue to you, I think B is easier because you will notice I already have a leading coefficient of 1, which means I get to kind of skip that first step of factoring out the leading coefficient. So I can go directly to what number could I sub in that is going to make that a perfect square. So I need to take my 6, take half of it, square it. That is my process. So 6 divided by 2, that is my 3. 3 squared gives me 9. I have to make sure I subtract the 9 right away. Do not forget about the -1. Common mistake. Okay, I can now factor my trinomial and at the same time collect on in the end. And pretty quickly, there is my vertex form. Okay, I think in doing those two problems, we actually have the opportunity to try some of these on our own. The numbers are going to get uglier. Do not let that deter you. Give it a shot. Work your way through. Yes, we might get some ugly fractions, but that's okay. We should be comfortable to work with them. Okay, I want you to pause the video and give C a shot. Okay, pause it now. Okay, we're back. I'm just going to put a little wavy line down, and this one I'll end up doing in blue, let's say. Yeah, no, I'll keep the same colors just so we can be consistent. Okay, I like it again. Leading coefficient is 1. I do not have to worry about factoring out. So I can go straight to completing the square. Except this is going to get a little uglier. Because when I take half of 5, it does not reduce. I'm going to be stuck working with some fractions. That's okay, though. When I square that, I'm going to get my 25/4. So I have to add in my 25/4 and subtract my 25/4 to make sure that the green is 0. Don't forget about the -8. Okay, I can factor my trinomial. Again, I'm not giving a whole lot of thought. Two numbers are multiplied to give 25/4. No, I know when I factor it, I already came up with that value earlier. So now all I need to do is put together my -25/4 minus my 8. So this is one where it might take us a little bit extra work. I'm hoping we can recognize that I'm going to have my -24 minus 32 all over 4 when I get my common denominator. And so that is going to simplify into a minus 57/4. There we go. Okay, hopefully that one went well, and we're getting more and more comfortable with this process of completing the square. Let's keep it going. Okay, so now we've got part D and part E. Try them one at a time. I don't think we should be that automatic with this yet, but we're just feeling more comfortable. You give D a shot on your own. We'll come back, we'll check in before we attempt E. Okay, pause the video now. And we're back. So I do have a coefficient out in front of my squared, so I need to factor out that negative 3 from both terms. Be very careful. We're factoring out a negative. That's going to change the sign. Hopefully that was not a spot of a mistake for us. Okay, now that I've done that, I'm going to complete the square. So I need to take half of negative 3 and square it. So that means that the value I'm going to sub in is going to be a 9/4 and then subtract it right off again. Because I had a coefficient of a, I've got to expand that out of the bracket. Okay, we should be getting a lot better at now factoring and expanding that out of my brackets. I think we should be okay to come in there. Factor the trinomial, multiply that negative 3 times that negative value, get it out of there. Now we can go ahead. I have it factored. All I need is to go through and collect in the end. Like for some of us, we're going to do this in our heads now. Like you're going to take that 27/4. You can already see to change 12 into fourths means you have a minus 48 of them. That's the calculation we're making. So my 27 minus 48 is a negative 21/4. There we go. I am hoping that that one went very well for you and that we're starting to build some confidence. Okay, what I would like to do now, I'm just going to shift over problem E for us. Here's your opportunity to try it again on your own. Okay, pause the video now. Okay, we're back. So, same thing. I need to factor out my coefficient. Now, if you're going to push buttons on a calculator, then fine, but you know I'm rolling my eyes at you. Some people may prefer that when you have a decimal that easily changes into a fraction, to do so. Like I know if I was going to work with this right now, I might not physically write out that red, but I'm thinking it. I'm absolutely thinking it. So that my first line, when I choose to go and factor out my 1/4 or factor out my 0.25, I know that factoring is dividing without dividing. So I need to calculate 3 divided by 1/4. And so I can see that when I'm dividing, I need to flip and multiply. So when I'm factoring out that a value, I can pretty quickly come in on my minus 12x. That doesn't come quite so fast if I'm thinking about it as 0.25. If I'm thinking about it as a quarter, pretty quickly. Okay, do not forget about your 2. Now I can go through and this process becomes really quick. I don't even have to write it down on the right. Half of 12 is 6. Square it is 36. Subtract it right off again. There's my 2. Hey, I didn't even change colors on you. I'm hoping we're feeling that comfortable. Okay, we can do 2 things. Let's go ahead and factor the trinomial. And when I multiply my 1/4 times my negative 36, there's my negative 9. You may have felt so comfortable that you collected that to a minus 7 right off the bat. Okay, I'm hoping that this is going well. I'm hoping that your confidence is building. Let's try one last one to see where we're at with it. Okay, what you see on your screen, there was problem F. I want you to go ahead, complete the square on that one, see how it feels. Let's pause the video now. Okay, we're back. I would argue to you this is probably the ugliest one that you would face because of the nature of the numbers in the problem. I'm going to walk you through it, but still relatively quickly. When you factor out your negative, you have to be conscious to change the sign. But also when you factor out that factor out that 2, it does not divide evenly. So you're left with a fraction. Well, now, when you go through, you have to take half of 3 halves. So when you take your half of 3 halves and divide that by 2, I'm hoping that we can see that as a 3/4 pretty quickly. I'm hoping we don't have to go divide by 2, which means flip and multiply, which to divide by 2, double the bottom. So now I need to take that 3/4 and square it to figure out the value I'm going to sub in. That gets me my 9/16, and there is what I need to add in and subtract to complete the square. Okay, now I need to go ahead and factor and expand and do all of that. So we should be pretty quick to be able to factor to that. You can see the 3/4 in the green. When I expand, I'm just going to get rid of that red on the right. We've already used it. When I go through to expand my -2 times my -9/16, then what I'm going to notice is when I multiply, I'm going to have a negative times a negative, so there's a positive. But also, notice that that's going to cross-reduce. Rather than writing down 18/16 and then having to reduce it, just reduce it right away, that I'm hoping we're good to reduce that to our 9/8. Maybe, in terms of practice, if you're already writing that down, then go ahead and change the 10 into 88ths right now. That might speed up the process for you. Now all we need to do, collect outside the brackets. A positive 9 minus 80 is going to give me a negative 71/8, and there we go. Okay, I'm hoping that you are more comfortable with completing the square than what you were at the beginning. I'm hoping that this gives you several examples to work through. If you are somebody that is very serious about math, then this should be something that you are trying. However, this is not going to be a dominant way that we go and change into vertex form in our course. Okay, so you may choose to get a little extra practice with this process, or you're going to get really, really good at using -b/2a. Okay, best of luck to you.